All right. So can you hear me clearly? All right. So everybody can hear me clearly, and so which means today the net connection seems to be good. All right. So before we start, do you have any questions for me? So all right. So no questions for me, and yeah. So some of you are basically a little upset about it getting little too technical. Okay. So I will describe again, and then we will talk about before going ahead. Okay. Yeah. Yeah, Nitika, go ahead. Regarding lab access, what? Yeah, yeah. So out of three, I'll have to opt only one, not three. Okay. So I've given the Tuesday as the date for you. All right. I believe that more than half an hour will be sufficient for you for quickly getting started. All right. Lab access will be there for next 50 days for all of you. Okay, it's just for getting started for on how to use things. Although you can do it by yourself also if you go through installation document, but in first go it's not very obvious. All right, all right. Okay, so yesterday we basically started with our the place we left off our previous sessions. Okay, and so we went quickly through the web interface. How do you copy file to HDFS, and how do you see the locations of various blocks, which we had already talked in session number 2. Now, then yesterday we also talked about how to execute a MapReduce command. This was a sample one. Now, afterwards, we talked about a very simple use case of finding distinct words in a big text. Okay, given a text, how do you find the count of unique words? Okay, and so we talked about various approaches and the pitfalls about those approaches, and then we talked about how do we solve the same problem using MapReduce. Okay, so how do you solve the same problem in MapReduce? And then we went ahead and discussed in detail what is a MapReduce and how does it work. Basically, MapReduce is more like your group by clause. In group by, you define that on what column do you want to group by. Okay. When you define that this is the column on the basis of which I want to group my data, in the similar manner, you define a field, a key. On the basis of that key is your data is sorted. So this definition of key is done by the map function you define. All right. And the aggregation for each key, the how should we aggregate the values is decided in reduce. Okay. So So MapReduce is very similar in the approach to our group by. Okay. In group by, we say group by a particular column, and then we apply an aggregate function on all the values for each distinct column values of the field which we are trying to group by. Okay. So for example, we are saying select word count star from table group by. What are we trying to do here? We are trying to first, we are trying to group we are trying to group the rows based on this particular column called word. Okay. For each word, all the rows containing the same word will be grouped together. And how should they be grouped together? By count. Okay. What should we do with them? You just count them. Okay. In the same manner, in the same exact spirit, the map reduce function works. Okay. In map, you define how should your data be grouped, and in reduce you define what should happen with each group of the data. All right. So example of map reduce is, say here what we are trying to do is, for so this is one example of map function. What does this map function do? It takes line by line input, and then it breaks down that input into words and prints out key and value. Okay. So on the basis of this key, the data will get sorted and ordered, and after that it will be grouped together. Once that grouping finishes, then on each group of values, the reduce function will apply. All right. So for example, here all we did was we broke down the one line into multiple key value pairs. Okay. Such that one word in one line. And so this is how we generally do a map reduce. Okay. As part of map, we keep on printing key value. And what Hadoop does with these key values is it groups these key values on the basis of a key. And it look like this as the output of the Hadoop. And after that, the each of these key and values each of the key and its values will be passed to the reduce function, and now it's the duty of reduce function to convert to decide what to do with the array of values. How this array is created for a single key, that's a Sweta's question. Yes, it is created by Hadoop for you. All right. So if you think about Hadoop, Hadoop is a giant group, group by clause. Okay, it's a giant group by clause. Or you can also think about group by is actually more about sorting, right? So MapReduce you can think of as if a big group by where the sorting is done by Hadoop, and then your map and reduce functions are executed by Hadoop. Okay. All right. So you will see just now in a minute of time. So after this here, so this was an example code. After that, we talked about something called streaming job. In case of a streaming job, yeah, just hold on, Nitika. Yeah. So in case of a streaming job, we can do the same thing without writing code. You can do the same thing by using any existing program or by using a script. All right. So in case of a streaming is also a way of writing MapReduce. In normal MapReduce provided by Hadoop, you have to write your code in Java. The map function you will be writing in Java, and reduce function also you will be writing in Java. But thanks to streaming job, you can utilize any of your existing binary or your shell program as a basically mapper and reducer. Okay, here again, here we define that SED is our mapper right now, and what we did was, as part of SED, we broke down the full line into one word per line. That's all. So, so the expected output, Hadoop expects your mapper to give out key value pairs, right? And the key value pairs in case of streaming job should be tab separated. All right. And Hadoop takes those key value pairs and then sorts them, groups them, and then for each of the key, all the values are brought together by Hadoop for you. And all these values which are brought together, they are given to your reducer, and then that operates upon it. All right. Just that in case of a streaming job, it does not do grouping. It only sorts the data such that all the same keys come together, and hence all the values also come together. All right. So Vikas's question, let me take up one by one. So Nitika's question is, when we write proper map reduce program, then what we have to write at this place? So I'll show you today that part. So yesterday we talked about streaming job where we utilized these commands, these simple commands as our mapper and reducer. All right. Now, Vikas's question is, can we ask Hadoop not to sort key value pair? Yes, definitely. So that too we discussed yesterday. So here, when we were talking about controlling a streaming job, you can say map reduce task equals 0. Okay. So there will be no sorting afterwards. All right. So all right. So the way we counted words was very simple. First, we made each word as the key, and value is just some number one. Okay, as you can see in these diagrams, all we did was, and not this, yesterday's diagrams. All right, let me just open up yesterday's session. All right, so yeah, the way we did was, here this represents the key value pairs. Our map program took this input, converted into key value pairs like this, and then Hadoop took these key value pairs, sorted them. After that, after sorting, it merged them together. Okay, so it sorted these key value pairs. You can see those are sorted now at the third level, and after that, it grouped them, and then it gave each key and value row. You can think of each of these at a time to your reduce function, and then your reduce function combined them, as in summed up one, and we got the results. All right. So I hope the paradigm is clear to all of you. Okay. And okay, so yeah, so is my voice breaking, or again. All right. All right. So, okay. So, yeah. So, what's your name? The login is showing as MacBook. Is that Huda? I'm trying to guess. Yeah. All right. So, yeah. Let me repeat it once. Probably it was not clear. Okay. So first is that we start. Hi. Yeah. So here you can see that Hadoop will take your mapper and give it each line of input. Okay. And your mapper is supposed to convert that line into key value pairs. Okay. For simplicity reasons, we just think about input as a single line. Okay. Now, in our case, our word counting case, as some of you told me that all we need to do is we need to group by the word and count or do a count star, right? Similarly, in our MapReduce program, we have made the word as the key and value is just number, any number. It could be one or it could be just X. Okay. So we converted each line into key value pairs. Okay, here key you can see sa, re, ga, sa, re, sa, ga, and value is just arbitrary one. All right. Then this is the output given by our map function, and this output was taken by Hadoop, ordered by Hadoop, and then grouped by Hadoop for you. All right. And once it has grouped, now what to do with these values? This array of values is decided by your reduce function. So Hadoop will call your reduce function for each of this combination, key and value combination. For each of this, so your reduce function will be called 3 times, while map function will be only called 1 time because there is only one row. Okay, if had there been 1,000 lines, your map function will be called 1,000 times. Make sense? If no reduce is to be called, Sweta's question is, if no reduce is called, then whatever is this output will be saved onto the HDFS. Okay. Now, once and our reduce function, all it is doing is whatever number of ones are there, it just sums them up and prints that as the count. So if you see, Sa has come 4 times, and in this output, total output, if you look at the Sa has come 1, 2, 3, 4 times. Ray has come 2 times and Ga has come 1 time. All it did was it summed it up, right? So that's the duty of our reduce function. Okay. Now Sweta's question is, if there is no reduce function to be called, so after your results are there, right? These results go back into the disk and saved onto the HDFS. They don't go back to the disk, they are saved onto the HDFS. All right. The sorting and merging is done where? That is a very good question, Vikas. So let me again step back. So now the same map function what we talked about is going to be run on multiple machines, converting all the inputs into key value pair, right? So you have split 0, split 1, split 2. Split 0 is corresponding to each block we had stored in HDFS, right? So for each file, say there are three blocks, and there would be, for time being, let's assume that for each block there is only one input split. So in input split is, you can think of around the block, it is a nice envelope. All right. So for each block or each input split, your mapper is going to be run one record at a time, converting each record into key value pairs. The record means each individual line, and these key value pairs are first going to be sorted on each machine, here, here, and here. So there are three times the sorting is happening, one on one node, another on another. So these key value pairs are individually sorted. Now they need to be merged together on some other node. All right. So here these all key values will be carried to a central place, to a node which will run the reducer, and then they will be merged together such that the overall outcome is still sorted. And once the sorting finishes, then the grouping will happen here only before giving it to the reducer. As you can, if you think about it, if you have sorted the data, grouping the data is not a big deal, right? If you have sorted the data by the key, grouping the data by the key is very, very easy. All you have to do is go from top to bottom in the key value pairs. The moment you observe a different key, so all the values which you keep, if the key is same, that means the value has to be added into the array. If you encounter a newer key, then it's a different case. Okay, so sorting and grouping is not two different things. Okay, it's a very minor differences. All right. Now after sorting and merging, for each key, all the values have come together and are given to your reduce function. And reduce function, whatever key and the value, reduce function gives out a single value. How is it going to be saved? What will be the output is decided by the reduce, and the output is saved into HDFS. Okay, so yes, merge is done on the reduce machine. That's correct, Tarak. Now question from Nalini is okay. So Vivek, you got your answer. This node where sorting and merging is happening will be the node where reducer will be run. It can be either of these three nodes or it can be some separate node based on the availability of the node. Okay. Now Nalini's question is, can we run reduce function at a later stage? Right. So okay. So another twist to the story is, when you are handing over your work to Hadoop, you generally have to specify what all things. First, a input file, the input file on which your mapper will be applied. So one input file, the output folder. The output folder should not already exist. Okay. Input folder or input file. If you are providing an input folder, all the files inside the input folders are concatenated together, and then it is considered like a one huge file. All right. Now input file or output folder, map function, and reduce function. Okay, these are few things you need to provide to Hadoop. And now both mapper and reducer are optional in nature. If you do not provide mapper, Hadoop will try to figure out its own key and the value from the input data. And on that basis, automatically the sorting will happen and the data will go to the reducer. If you do not provide reducer, okay, you do not provide reducer, then Hadoop will try to basically just combine together. It will not reduce the values into one. It will keep all the values as such as like an array and save it to the HDFS. But you can also mark that, hey, I do not want any kind of sorting. That you can specify while running MapReduce. Okay, but keep in mind Keep in mind, you can turn off the sorting only if you have not provided a reducer. All right. So, okay. Well, let me just go through, take out all the questions in a separate txt, and right. So yeah, this is answered. The sorting and merging is done where means this is answered. Can we add reduce function at later stage? Yes. So if you want to run a reduce function at later stage, probably you are breaking down your map reduce into two phases. Okay. MapReduce takes input from HDFS, writes the output to HDFS. Okay. In the same manner, you can basically pipeline one after another. Your next one will read the output provided by the first one, and so on. Okay. Please take a machine learning example for MapReduce in future session. Okay, we will take that. No worries. But it's not generally required. That will unnecessarily complicate the concept, simple concept. Okay, go ahead. And yeah, we will go through those four problems we discussed yesterday. Is the merge done on reduce machine? That's correct. It is done on the reduce machine. Okay. And Huda's question is, at each node, the mapper is run, but the reducer runs on one node. Yes, from this diagram, it looks like that reducer is being run at only single node, right? But what happens is, in case you realize that your reducer node is overloaded, and it's taking too much time, you can tell Hadoop that, hey, can you run my multiple reducers? If you do that, it will look like this. If you have multiple reducers, your the output given out by your map function will be divided into two buckets. One key will go into one bucket, other key will go into other bucket. This way, if you have n reducers, there will be n buckets here. Right now, since we have said that we want two reducers, we are having two buckets here. All right. So this way, bucket 1 is carried to the first reducer, bucket 2 is carried to the second reducer. It is always ensured that same key goes to the same reducer. It would not happen that some values for key went to one reducer, some values for the key went to another reducer. Okay? It will never happen. All right? Now, Huda's question, I mean the merger is run on one node, but the sort run on each. Yes. So sorting of each individual section of the data is happening on each individual node. And then the merger of this sorted data is happening here. And recollect that merging a sorted data is far more easier than sorting the unmerged data. Okay. And we gave you a demo. I gave you a demo on how do I merge three sorted arrays. All I do is I start from one side and pick up the smallest one from them, and then remove that one, and then keep on doing that over and over again. Okay. All right. How system knows which node is available to be used for reduce function? Good question, Goel. So yes, so since the job tracker is the one who is giving out the resources, it exactly knows where was the last resource handed over, and which are nodes are still being used. Okay, so all of this is the duty of job tracker. It takes care of all these things. All right. That is correct, Vikas. Mishra. So reducer can also run on either of these three nodes based on availability. Okay, but most likely what happens is when mapper is being run on these three and Hadoop is starting up reducer, most likely all these three nodes will be marked as busy. Okay, marked as busy, and therefore reducer will most likely run on some other node. All right. Nitika's question is sorting is and merging is done by Hadoop internally, then okay, just a second. I need to understand this question. So Nitika's question is sorting and merging is done by Hadoop internally. Completely agree. Then after reduce function begins. No, before the reduce function begins, sorting and merging of the data has finished. Here we are using merging in the context that data from all three nodes is being merged here. Okay, and after that for each key all the values we have collected from all other three nodes, and then the reduce function is executed for each key against all the values as well. All right, now what is the rollback process if something goes wrong? There is no rollback process. It's just that the output is completely discarded. All right, good question again, Harshal. So what happens is imagine that there was this reducer node and it failed. It failed completely. So again, some of the mappers had finished, some were under process, and some were again under process. Reducer, it failed, and Hadoop was unable to. It even tried to relocate more resources, but it did not work. It tries couple of times, then it gives up. So what happens is all this temporary the output is completely discarded, and an error message is sent to the job owner like you who has scheduled the job that your job has failed, right? Or it just basically update the web status saying the job has failed. You can keep on refreshing and check. All right. Now, okay. So it will definitely impact the other mapper and reducer, because if one of the things, say reducer failed, okay, or one mapper badly failed, so the whole job has to be abandoned. Okay, so the whole job has to be abandoned, and it's like saying that see, we could not complete one part, and there is no point in giving any result. So the whole job across the cluster is killed. Okay. Okay, so it tries as much as possible. It has a fair amount of resilience. If it fails on one node, it gives around three times of trial on other nodes and tries to execute the job. If it fails even after three times, then it gives up. Okay, you will get an error message. The process will get updated saying map has failed or reduce has failed. Okay. Tarak's question is, in that case, will it restart? So it has already tried enough. It has now given up. It will be your duty. You can restart the job. Okay. Perfect. So everybody is on the same page now. I know I am repeating a lot. Hello. So yeah. Has the voice breaking again started? Is it again starting to break? Okay. All right. Good. Good. So for most of the people, the voice is not breaking. That means fault may not be on my side. All right. So yesterday we left with three problems. We will discuss those three problems now. All right. All right. So we computed frequency of words by making each individual word as the key and one as the value in, a- as part of our mapper. And in part of reducer, all we did was we summed up all the values for each word. That gave us the frequency of words in the text. Now, my question to all of you is frequency of letters. Frequency of letters, if we have to compute frequency of letters, do you need Hadoop? Do you need MapReduce? Yes? Nitika says if the file size in gigabytes. Gigabyte as in 100 gigabyte or 1 gigabyte. So Vikas says that we need it if it doesn't fit in one system's RAM. My question is, do you really need to fit into the RAM? Why do you need to fit that into the RAM? I'm looking for only the frequencies of alphabetic characters, that too the lowercase ones. I'm only looking for the frequency of the letters without case sensitiveness. Capital A and small a is same. So what will become the bottleneck? Will it be the RAM in this case? Will it be the discretes? Will it be the uh, will it be the CPU? Okay. What do you think will be the bottleneck? Correct. So disk speed is something which will become bottleneck after we go beyond some 100 GB. So reading around 1 GB takes close to 4 to 5 seconds from the disk. Okay. So if it goes to hundreds of GBs, only then we have to worry about disk speeds. Okay. All right. So the general approach is that you keep on reading the file from left to right and top to bottom. And if you encounter A, and you maintain this array called counts, okay? Count 0 represents number of times you have encountered A. Count 1 represents the number of times you have encountered B, and count 25 represents number of times you have encountered Z. Initially, all this array of counts is 0, and when you read this file from top to bottom, left to right, as in when you encounter A, you increase the zeroth value in this array of counts. If you encountered B, you increase the first index in this counts, and so on. Okay. This way you can compute the frequencies of ladder. Sounds very straightforward, correct? Now, the problem with this approach is the, the network or the disk IO will become the bottleneck, or maybe the CPU might become the bottleneck. All right? RAM will not be a problem. Now, in case we go into hundreds of GBs, then reading the data from disk will take time. So it would be better if we utilize multiple computers to read the data from disk and do it parallelly, and then we can merge these counts together at a later point of time. Now, do you think how okay, let me ask it another way. So, how should we write MapReduce to find the frequencies of letters? Anybody? So what will our map give? What will be the key and what will be the value should your map function give out? Okay. You don't have to specify a number of mapper functions. That is totally decided by Hadoop. You write your function, you write the logic that how many keys will be given out by your mapper function, what will be the key, what will the value, and Hadoop will take this program and run it on all across nodes. Good, good. Great, Sweta. Yes, that is a right approach. Key will be alphabets and value will be 1. Okay, correct. That is correct. Because we do not know right now how many times the occurrence is there right now. So, okay, so there is no point in saying value equals occurrence. Alright. Only we can do is we can only do for each row and then combine them together. Alright. Perfect. Yes. So you can think of your key value as alphabets and the number of times the alphabet has occurred in each line. So Huda's point is on what basis we give out the value. The idea is uh, either you can give 1111 each because reducer will sum up all the keys or all the values for a key, right? And that's how you want to count, correct? Right. So every time you encounter a character, what you can do is you can give out in the output saying A has occurred once. Again, B has occurred once. So it will be A1, B1, C1, D1, and so on, or F1, Z1, whatever. And at the end of it, it will basically order all the key, all these this data by alphabet, and then it will sum up all the values all the values for each of the alphabet, right? So just the way we did for word count, we are trying to do the same thing for character count. All right. So Tarak's question is, it is basically for count exactly. So we can give any number instead of one. Yes, you can say x x x, right? And then instead of saying sum, you say count. In your reduce function, instead of summing one one ones, you just say count how many times one these things have occurred for each key. Correct? Great. So everybody is on the same page here with me. Here we are doing a little bit more optimization. What we are doing is, so if you recollect, your mapper function will be given one line at a time, and your mapper function's duty is to convert this line into some form of key value pair as per your objective. So one approach could have been that we just take all the characters from this line and print out each character and one, right? Other approach could have been that we do the frequency analysis for the whole line and then we print the frequency for each line, correct? So this is what I'm trying to do in mapper 1. So if we take the whole line, do the frequency computation for this line, and then we print it out, and then Hadoop will group these things by each character, and then we sum it up. All right? Sounds good? Sounds good to everyone? But you should note that there will be, say, if you have a billion characters in your file, so a billion key value pairs will be transmitted from mappers to reducers, right? Because you will have a billion key values and they have to be combined together and have to be transmitted to reducer, correct? So this approach has a very huge scope of improvement. So instead of sending a billion number from each mapper node, so each mapper will compute this key value pair. So there will be millions of key value pairs on each node because we are doing it for each character, right? Now, if we have to transmit these data from each mappers to reducer, we have to transmit all of this data. What if we could do some operation on each node, whole node? If you could do an operation that which can summarize in some way, then it could have been great. And that's what is the role of a combiner is. Combiner combines the result on that node before it is being sent to the reducer. Okay. All right. Now Sweta's question is, if line break is not there, then there will be an issue in approach. Yes, in this approach, even that issue will be there in any strategy. Why? Because the way we are providing the input to MapReduce, it's going to read the whole data as a single line, which means only single call to your mapper will happen. All right. So in both the approaches, that will fail, not only in the second approach. If you have no new line in your file, then there will be a problem. But there are ways to tell Hadoop that, instead of reading line by line, can you read some other way? All right, is everyone with me? All right, so the frequencies of letters is okay. So moving on to the second question. Second question was, find the anagrams in a huge text. Okay, an anagram is basically different arrangement of the letters of a word. Okay, so cat, act, tack is same. All right. So now question is, has anybody attempted this question? I have not been able to review your answer sheets yet. Sweta says word, an array of characters. So So as per Sweta, the key is going to be the word, as in the will be the, right? And the value will be array of characters. Is it? So the idea is to bring the anagrams together. What should be the key for each of the word such that all the anagrams of a word form the same key? What is it that is common in all anagrams of a word? Thank you, Vinay. Excellent. Key will be the sorted letters in a word and value will be the word. Excellent. Marvelous. So basically, as Sanjay says that the it is the same number of letters, same letters, which is commonality between all the keys. So if you want or all the anagrams, if you want to bring all the anagrams, we have to form a key which should be same for all, right? Same for all the anagrams, and that would be take all the letters from each word and sort the letters, okay? Sort the letters, and that should be the key. Yes, that's correct, Nitika. Excellent. So now next diagram shows you what will be the output results of each of the mapper. Mapper is your code. You have to write this code such that it takes a whole full line, gives out key value pairs in such a manner. For the for the so it break down the line into words, and for each word what did it do? See, for the it took out EHT, ordered them by in ascending order. E comes before H comes before T in the alphabetic, and that's why the key is EHT. For cat, again, A comes before C and C comes before T, and therefore act is the key and cat is the value. Similarly, act and act, right? In case of act, it is same. Now, if you look at it, all the anagrams cat, act, and tack, they are going to have the same key. That is, the key is ACT. Make sense to you? All right. So there is one more approach you are talking about, or the key can be created using weighted approach on characters. Okay, that is going to be a difficult situation. That is definitely going to be a difficult situation. The only way you can prepare the key is by having a positional number of 27, okay, and you multiply 27 by the value of each character, and then yeah. So yeah, that is going to be a little tricky, and the tragedy with that approach is it will quickly overflow even the long, even your long number is going to be overflowed by that key, right? So Tarak's question is, in previous questions, are we finding anagrams or number of anagrams? We are finding anagrams here. We are finding anagrams, and even if we have to find number of anagrams, then also we will have to go through this kind of approach only. Okay. But number of anagrams will be a little difficult question actually. All right. So Harsal's question is, what how mapper knows to look words instead of characters? All right. So see, the mapper will get one line at a time, right? So mapper is your function. In this function, in the argument, you will get the line, correct? And as part of the function definition, you will have to break down that line by spaces or tabs such that you read one word at a time. Okay. And then and then for each word you break down the word into characters and then order these characters and form the key. Did I make any sense, Harshal? No, no, I mean, uh, did I understand question correctly? And all right. So is everybody on the same page? This question was fairly tricky. Okay. So yeah, there is no, I mean, in most of these languages, like it's not, they don't have a sorted function to sort the letters. So you have to, that is why these programming languages provide you a very low level access to each and every character. So you can sort these, sort by yourself. Okay. You can create an array out of letters and then sort that array. Every programming language provides a function to sort an array. All right. So for each word, you convert the letters into an array and then sort that array. Make sense? All right. Moving ahead. So this example is clear to everyone. Why did we form the key this way and not something else? Okay. So Sanjay, just hold on with me. If you want a pseudocode, I can write immediately. So, okay. So pseudocode, I think I should write it for you right now. Okay. And it should be easy. It should not be big deal. So let's say you are writing the function, okay, my mapper. You will be given a line at a time, or let me just write it in JavaScript way. Okay. So it will be like this. And then you say, words equals line dot split by space. Now you got words for word in words. Okay. For word in words, what you need to do is you can say word dot to array. Okay. So you can say char array, and then you can say array dot sort char array. All right. Now key will be sorted array equals this. Key will be your string. Again, we are converting array into string. All right. Now key, this is key, and we will basically print key, and value will be our actual word. So this is how, by the way of print, or we can write a better word, emit. Okay. So by the way of emit, we are telling Hadoop that this is key and this is value. Once we have written, and what will be our reducer function? Okay. Okay. Reducer will be, okay, reducer will be some key and say words. All right. So let's say that set there is okay. Um, as part of your reducer, all you do is emit key and we say unique of words. So I'm assuming here that there is programming language is giving you a unique function. All right. Yes, we will get array as the argument in the reducer function always. That's correct. We will always get that. That is the part of the function definition. Okay. So this is how your code will look like. This emit is how you communicate with Hadoop. All right. Although it's a pseudocode, when we talk about Java, the code will be little more uglier than this. So do not get intimidated. And to avoid that intimidation, I'm trying to write it here as simple as possible. Okay. All right. So let's take a 5 minutes break, continuing with our normal routine. All right. Hi, I'm back. All right. So, Sanjay, is that this code clear? All right. Today we will look at the Java code also after this. All right. So this is correct, right? So for each key we have values, and then we have the data got sorted by the keys and then grouped by the keys. This is done by Hadoop, and this is also done by Hadoop. And then in the reducer we basically only printed the values. Okay. We could further go ahead and print only in the cases where we encounter more than one value for a key. Okay. If you have more than one value of the key, that means there are at least two words that are anagrams. Okay. Also, we could do few more things, that we could compute the unique of these and then count. Good. Unique of the values. All right. Moving on to the next question. All right. So this, how many of you have thought about this one? It's a simple one. A file contains the DNA sequences of the people in this format. You have key and the value. All right. You have user and the DNA. Now, what do we want is we want to bring all the users together whose DNAs are same. Okay. So what will be the key and the value in case of a mapper, and what will our reducer do? Anyone? Perfect. Perfect. So good, Sweta. Excellent, Harshal. And yeah, thank you, Vinay. Yeah. So Nitika here, good, good. So DNA will be our key, right? DNA will be the key and user will be the value, and Hadoop will sort the data based on DNA and then group them based on DNA, which means Hadoop will automatically bring all the users together who belong to a same DNA, as long as your map function is giving out key as DNA. Perfect. So this one, are you okay with this, Huda? Are you back? All right. Yeah. So good. So we have this. In this case, we do not need to reduce it. Yeah, because there is nothing much to be done in the reducer. Had we been saying that count number of users who belong to the same DNA, so in those cases we will do the counting inside our reducer. Okay. Here all we have to do is concatenate the users by comma. Okay. That's correct. Good, good. You have already answered, Tarak. Thank you. All right. So, I mean, this should be very, very clear that all we need to do is select DNA, concatenate user from my table. This is the equivalent SQL command. All right. Now the next question, gradually moving up. So how many of you have attempted this? We have to bring all the users together whose DNA is either identical or mirror image. So what will be the common key amongst such users? So let's say some scientist says that all the people who either have identical DNA or mirror image of the DNA belong, these such people belong to the same family. Now, how will you, what will be your key in this case? Yeah, what will be your key in this case? So Nitika says key will be DNA, but that will not bring people whose DNA is mirror image. So as you can see here, user 1 and user 2 have to be brought together, correct? Tarak says sort the DNA, but then user 6 will come with user 1, right? Sanjay says, can the key be forward and reverse of the DNA? Okay, I want to understand that. What will be the key exactly? Either forward or the reverse. Okay, okay. So what will be the key for user 1? So you mean to say a composite key, right? Sweta and Sanjay probably? Okay. DNA, sorry. Okay. Can the key be forward and reverse with DNA? Okay. Now let me, I have got an answer from Nitika. Nitika says compare that. I want to understand that. Okay. Will be both keys. We need to, okay. Goel says that we need to divide it into two parts. First, first we need to create anagram and associate with DNA, and then we need to associate with DNA. So give me an example. What will it look like? The user one will have what key? Okay, I'm just copy pasting your question here. So because as you type, it scrolls down. So yeah, we need to divide it in two parts. First, we need to create anagram and then associate with the DNA, and then we need to associate it with the DNA user. All right. Okay, give me an example. I'm yet to figure out. All right, excellent. I think Sanjay has got it. Sanjay says that make the combination of the two things and sort them. All right, all right. Vinay, are you in the session? So any ideas? Or did I miss your answer? Hmm. I think Sanjay has got it correct. All right. Okay. Vinay says composite key makes sense. Yeah, but composite key, I mean, let's say that there is no such idea called composite key right now. And the key can be only a string. What will you do? Okay. First, with the arrangement of DNA, and the key will be DNA value, and then again with the DNA and the user. I need to think about this approach. Yeah. So what will be, so Huda, what will be the key for this one? This one, correct. The idea is to bring those users together, meaning form a key which will be same for user 1, user 2, and user 4. Okay. And user 3 and user 5 should have different but the same, but user 3 and user 5 should have the same key, and user 6 has some other key. Okay. So yeah, uh, Huda, have a look at this. Have a look at, if we sort the DNA, user 1 and user 6 will come together. Correct? All right. Sanjay, have you got the answer? You were on very right track. And I think Sweta was almost there. Uh, yeah. So key and the reverse of the key. hmm hmm So instead of sorting characters, if you sort the words, okay, it will be better. Yes, yes. For 1, 2, and 4, that will be the same key. All right, all right. So let me tell you my approach. Let me tell you my approach. So my approach is, there are three approaches possible. This is one of the approach. Probably you can come up with a better approach. So I'm saying, take the DNA and reverse it. So now you got two things. One is DNA, another is reverse of it. Okay. Now pick up the minimum one. Pick up the smaller of the two, either DNA or the reverse. Just pick up the smaller of two. And how do we say smaller? The one which will exist in the dictionary before the other one. So in dictionary things are ordered, right? So, and they are alphabetically ordered. So take a DNA, inverse it. Now pick the smaller of the two. Okay. So whether there is another user containing the same DNA or reverse, they will all have the same key. Let's take a case here. So for ACGT, the reverse is TCGA, right? And the minimum of ACGT and TGCA is ACGT, right? Similarly, for second user, TGCA, for second user, DNA is TGCA, and the inverse of it is ACGT. And what is the minimum of it? Smaller of the two? It is TGCA. Not sorry. It is ACGT. So Vinay says you could use DNA.compare to and then use this. Mhm. Yeah, that is also possible. That is also possible, but that will be very, very specific to the people who are working in Java, and that will actually be little complex. The way you can provide the sorting function, the compare to function to Hadoop is a different game. Okay, all right. So our tendency, instead of telling that how to compare two words to Hadoop, is instead of doing that, we specify strictly that this is my key. Okay. All right, is everybody with me? So basically, in this case also, say user 2, minimum of this and reverse of this one is ACGT, and then we basically do the minimum of it, and ACGT is the answer. Now, in case of ACG, in case of ACG, minimum of ACG and GCA is ACG. ACG. Minimum means the one which will come earlier in dictionary. Out of these two, who will come earlier in the dictionary? ACG, right? G will come in the later. Now, so this is clear, right? So this way we can group this data together by this complex logic, right? So now the last, so here our mapper gave this result, and this line, this big line, is what is done by Hadoop for you. All right, and then is grouping is being done afterwards. And note that when you are doing streaming grouping step, this Hadoop does not do grouping for you. Okay, it just gives you this in the reducer. All right, and reducer here is just not printing the key, it's only giving out the value. Reducer essentially again is not doing much. All right, the only thing reducer could do is maybe actually there's, if there are users repeated, then it can basically eliminate some users from it. Okay, so we have so are you talking about the same question, Tarak, that we have users with similar DNA, but how do we map the forward to reverse in the same DNA? Hmm, okay, let me take a step back. So so in this question, the objective was that we had to find out all those users who have either identical DNA or exactly reverse DNA. All right, you can see that user 1, user 2, and user 4 lie in the same bucket because user 1 and user 4 are say. All right, now Vinay says that can we have map function? Okay, so Vinay says, can we have map function that just does list, DNA, and user, and then in reducer combine? Not really, not really. So that's what I was saying, that reducer, whatever function you write, it will apply only on one key at a time. And in case there is a reverse DNA, that is going to be a different key. So these two keys, key and the reverse of DNA are going to be two different function calls, correct? So for first one, like here, this one is one call, and this one is another function call, and this one is another function call. Meaning this one is the input to the reducer once, first call. Second call will be this with this input, and third call will be with this input. Yes, reducer operates on a single key at a time, and mapper operates on one record at a time. Mapper cannot have access to all the records. All right, is everyone agreeing with me? Goel? All right. So this was another a little tricky question after the anagram one, and trust me, it is going to pay off if you are able to convert any problem into MapReduce. Okay, it is a definite, very big deal. Okay. All right. So now we have another question here. Did anybody attempt the fourth question? Mm-hmm. So, all right. So let me just open few things here. All right, people. All right, I'll have a take a look at it. If you can just copy paste your approach. All right. Yeah. Okay. So Nitika, could you just copy paste your approach? It should be there in your user account and my results. All right. So probably fourth is not attempted by any of you. All right. No worries. No worries. Okay. All right. So, yes. Oh, is it? Yeah, I'll have a look at it, Sweta. I'll have a look at it. And do you want more time for the fourth problem? You can take more time, it's okay. Does it make sense to give more time for the fourth problem, I think? All right. Take. I think it will be better that if we discuss this fourth problem later. Okay. I don't want to kill the suspense. All right. All right. Let's review the fourth problem on the next Saturday. All right. Because the most crucial one we have tackled, and based on these things, you can utilize those. The only suggestion I have before you attempt the fourth one, first you have to exploit the property that if you provide a folder, all the files inside a folder are merged together and fed to your mapper, right? Second is you can utilize multiple phases of MapReduce. Each MapReduce, because MapReduce takes the input from HDFS, puts the overall output into HDFS. So again, you can chain them together. All right. So I don't want to discuss it now. Go through this and come up with your approach. I'm sure you can actually come up with a better approach than mine. All right. Okay. So yesterday we talked about our mapper in case of a streaming. The way you have to test your streaming job is you first test the streaming job on a very small data. Okay. Specifically, whenever you are testing any of this streaming job or any of the big data work, you first test on a random sample. Okay. Do not do head or tail out of the data and then test. Specifically, when you are starting a big data project and a client is saying that we will give you few records from our data set on which you can build a POC. All right. You should specifically tell them that you need a random sample instead of head or tail. Okay. Because I've seen most of the people failing in real time is when they just take first few record or middle few records and last few records, and then they realize later point of time the data is heavily skewed and their approach will not work. Okay. So always test on very small data set first, but randomized set. Okay. And that's why you will find almost every big data solution provides a way to give you a random sample. Even Twitter gives you a random sample. All right. Also, always separately test mapper and reducer. Okay. You know that what should your mapper give out and you know what should your reducer give out. So independently test both of them. All right. Next is if you are testing a streaming job, the beauty of an streaming job is that they streaming job the mapper and the reducer can be tested by a simple command line just like this, because the mapper and reducer act like a normal pipe, right? Normal filter, not pipe, filter, something that takes input from standard input and gives out this output to a standard output. So if you have to test a mapper and reducer, you can simply say cat my input file, right? give it to mapper. Now mapper will produce key and value, then sort it, and then give it to reducer. So you can simply test your mapper and reducer from command line this way in the shell. All right, without having to send your mapper reducer to Hadoop or to cluster. Okay. In case you're using Java, then you can use MR unit. We'll talk about it. And the fifth point is very important. Most of the big data problem you will be solving, uh, maybe half of those problems would be related to predictions. Okay, because any big data solution will be pretty good with predictions because of law of large numbers, and most of these solutions are built for predictions, forecast, prediction, recommendation. All right, and all of these systems, if you have to test them, you should basically break down the data, sometimes chronologically, meaning take first half, which was older data, and try to predict and match those predictions with the second half. Let's take a case of movie rating. So say you are building this brilliant system which gives people the recommendation on movies, that this person will like this movie, and so on. All right. Now, somebody came up and built this brilliant system and it gives awesome recommendations. But how do you know that these are really awesome? How would you test? How would you test an oracle? Oracle means somebody who predicts the future. How would you test uh, somebody who is telling you the future? You basically ask about the past, meaning you take whole data set, divide it into two halves, run your recommender on the first half, and then, assuming that it's telling truth, compare it with the second half. From the first half, it would say that Vinay would like a movie called, let's say, Matrix, right? Now you compare, did Vinay actually liked Matrix? And how close are we? If Vinay liked Matrix and Vinay has rated Matrix as 7 and recommender is saying 9, there is a distance. All right. So to test predictions, probably you have to basically come up with brilliant designs, and testing is a part of development. It has to be part of product planning. It's a part of product management. So and it is doubly so when you are talking about big data. Most of the strategies have to be designed in order to test. Okay. All right. This we'll not talk now. Uh, okay. So for today's assignment, okay, we have this question to you. Yes, that's correct, Vinay. That's correct. Yes. All right. Now, I I have one more question. So, when you are typing using your keyboard in Android and you type a word, it gives a recommendation immediately, right? So, if you have to design such a system, then what are the things you are going to do? Okay. So, here the objective is to go through a huge corpus of text and figure out what are the common words that follow a particular word. What are the top 5 words that follow a particular word? For example, if somebody is typing happy, there are high chances that he will type birthday, okay, or new year, or something like that. Yes, you have to develop n grams. Specifically, this is called 2 gram because we are only talking about 2. Okay, and 3 gram is somewhere, if based on last two words the user has typed, what should be the third word? That is 3 gram. Okay, so this is what we want to do. All right, so think over this. Basically the text is available. You can download the text of whole Wikipedia as text from here. Okay, and then you can figure out just a general approach. A very high level approach is good enough. Oh, nice. I'll have a look at it if you share the, a link. I'll have a look at it, Vikas. All right. Yeah. So the problem statement is clear to you. Given a huge corpus of text, you have to basically find out top 5 recommendations after a particular word. Meaning, most frequently occurred word after a particular word. You have to find that out using MapReduce. So is the problem statement clear? All right, so go through the assignment. This is the common slide everywhere. And yeah, ouch. All right, so good. Yes, it's a one question in tomorrow's assignment. All right. All right. Now let's start with our. All right. So I will actually, the problem which I just stated, I will give an approach and I'll tell you that this is wrong and you have to come up with a better version. Okay. So this is my problem. Okay. So my first approach is to break it in such a way that my key is first word. So each combination of word results in a one key. Okay, how are you, and so on, right? Now automatically all the values that are following a particular word will group together, and then we can solve it. Now problem with this approach, you must have noticed that we want to group you and Ram together, right? But they are in different lines. Okay, so there are multiple problems with this approach and you have to figure that out. Okay, so now we are going to discuss few more things. First we are going to discuss the Java MapReduce, and then we'll discuss few more things. All right, so before that, few more questions. So the data generated by the mapper is given to the reducer and then it is sorted. Is this correct or not? Yes, yes, all of you are correct. It is no. All right. So the output of the mapper is first sorted and shuffled, and then reducers are called. Great. The mapper can only generate a single key value pair. For each input, for each input, your mapper can only generate single key value pair. Is that correct? All right. So Vikas and Tarak are the two who says the true. So for each line, like in our case, we were counting words. Did a single line produce multiple key values or single key value? Tarak and Goel? Tarak and Goel? When we were counting words, the input to our mapper was a single line, right? Full line. So did our mapper for each single line generate only one pair of key value or did it generate multiple? It generated multiple. That is very correct. So yes. False. The mapper can generate as many key value pair as it wants for an input. Perfect. Perfect. All right. Now next question is a little tongue twister. Little A mapper always generate at least a key value pair. Correct or wrong? A mapper always generates at least a key value pair. Or mapper always have to generate, okay, let me make it a little more arrogant. Always have to generate at least a key value pair. Now, still, no, actually, that is incorrect. It's wrong. Vinay is correct that it's not compulsory to generate a key value pair. Okay? Imagine that in a line you only encountered special characters and you don't want to generate a key value, right? Yes, that's exactly the reason. There may be thank you, Vinay. There may be some business logic due to which there may be no key at all, right? Let's say there is a line and we realize that line is bogus, right? It only has special character. We want to ignore it completely. We don't want to generate any key value. We can do that. All right. So you can say for an input record, your mapper function can generate zero or more key value pairs. Okay. Yeah. So let's have a look at it and let's have a look at it. So okay. Now let's say we are still, let's talk about word count example. Okay. So you have to tell me this is a book. This is a book and space, 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 tab, tab, tab. This is another book. Okay. Now dot and then. Now you are counting words. Okay. How many key value pairs will be there for first one as per your mapper? Nitika and Huda. When we are counting words, you will generate key and value, which will be word and one. So for each word, you will generate one key value pair, and hence, how many key value pairs will be there for first one? First line, four. Perfect. And the second one, zero, correct? Because there are no words in the second line. but it will be given to your it will be given to MapReduce. Hadoop will give this as a record, as a line to your mapper and say, can you generate some key value pairs, please? And mapper will say, I don't want to generate any key value pair for this. Correct? And for this one, third line, how many? All right. I think I made the point, Huda and Nitika. So the mapper does not always have to generate a key value pair at all. Okay. Next question is, a mapper, by default, there is only one reducer in case of streaming, yes or no? Okay, Shweta, I want to understand your reasoning. Yes. So, by default, in case of reducer, in case of streaming, there is only one reducer, meaning there is only one node on which the reducers run. Okay, your reduce code runs. Okay. Yeah. So by default, when we are talking about streaming, by default, if you do not specify how many number of reducer node you want, then by default there is only one reducer. Okay. You can change it as per your wish. Okay. By default there is a single reducer job, but it can be split by specifying command line option like this. Okay. All right. But in case of Java MapReduce, the interesting part is number of reducers are decided dynamically. It is started happening only lately. Earlier, there was only a single reducer by default. Okay, now another question just to check if we are all on the same page. What is the role of reducer? What is the role of job tracker? A or B? A is executing the MapReduce logic or delegating MapReduce logic to task tracker. Perfect. Perfect. So yes, B. Now, the map logic is preferably executed on the nodes that have the required data. Great. Yeah. Now, same question in a different tone. Map logic is always executed on the nodes that have the required data. Excellent, excellent. So everybody is able to answer this. Perfect. So Goel, you are probably answering the previous question, is it? Good, good. All right. So you are correct. The map logic is always executed. It's not always executed. It is mostly executed. But in case there is no resources available. The computer is busy. The computer that contains the data is busy, and all the computers that contain the copy of that data are also busy. Then the logic is executed on the nearby computer, and we'll talk about it. We call it data locality. Okay. Now, next question is, where does Hadoop store the result of the reducer? HDFS or local machine? On that node's hard disk, or in the HDFS? Brilliant, brilliant. So, great. All right. So, in HDFS, perfect. Now, this one is little tricky. Where does Hadoop store the intermediate data, such as output of map tasks? In the HDFS, or in the local file system, or in the memory? Mhm. Okay. So all of you are agreeing that it will not definitely be in the HDFS. Okay. Tarak says result is compared in the node but is stored in HDFS. So I'm assuming Tarak has an account in HDFC. So yeah. All right. So, but it's stored in HDFS, right? No, I'm just making a guess because I also tend to type HDFC the day I check my bank account. So, all right. So results are compared in the node but stored in HDFS. Hmm. So yeah. So because this intermediate, okay, okay. So because this intermediate data is useless fairly, right? Because as soon as the job is over, this intermediate data is not of any use. So what you do is, imagine that if HDFS, if we move this data, intermediate data of each individual node to HDFS, then there'll be replication, there'll be too much of engineering around some data which is going to disappear after 5 seconds, correct? Or maybe after maybe 10 minutes, this data is going to be useless. So it is too much of an expensive work to move this data to HDFS. Therefore, first, correct answer is the output from mapper. When your map function is giving out the output, the key value, it is written into a list, circular list, basically a big circular list. From one end, this thing keeps on pushing, Hadoop keeps on pushing the data into the circular list. From another end, it keeps on consuming it. Okay, that's how it generally works. Okay, so first it's written into the in memory kind of data structure, and then it's pushed onto the disk. Okay, so you can say, at the end of it, it is stored in local file system, but for some time it is kept in the memory. Okay, if I had only given you two options, the answer was definitely, let me also correct this, first in memory and then purged to local file system. I think this is better answer. All right. So when mapper is running on your machine on the node, so it would be performing the operations at a very fast pace, right? So it is better to write it to the memory and purge it in a bunch of say 10 MB or 20 MB or so in a bigger chunk to the disk. Okay, and this size, how much this size can be there, how much in memory size can be consumed, can be configured at Hadoop level. Okay. Yeah, so it is waste of the memory. So basically it is useful as long as the data is not sent to the reducer. So first, your mapper is spitting out key value pair very frequently at a very high speed. Your mapper is spitting out the key value pair, and these key value pairs are being accumulated in memory and then being written to the disk. Okay. Once all the mappers have finished their job, or in the meanwhile, uh, this data is also kept on being sent to the reducer. Okay. And why is it kept in the disk is in case your reducer died, and now while Hadoop is trying to execute reducer on any other node, so it can spawn or it can create reducer on any other node and again send the data from local disk, right? So that is why it is stored locally. If it was not stored locally, then if we have to send it again because the reducer has died, we were not able to execute reducer on that particular node, we are trying to execute reducer on some other node, then we would not have data for that. Does it make sense? Huda now was able to explain. So was that concept clear to all of you, that why it kept in the disk? If you want, I can explain again. Now, another question. The whole of HDFS block available on a node is fed to the mapper. The whole of HDFS block available on a node becomes the input to the mapper. All right. So here is the anticlimax. The answer is no. The answer is no. Why? If you remember, the input block, the input data, the block which we created in HDFS was a ruthless, it was cut ruthlessly exactly on 128th byte. Okay? It was cut exactly at 128th byte. Now, if that line where it's cutting the data is on a word, think of your word count problem again. If it was cut, if that line was in the middle of the word, half of the word will go into one block and half of the word will go into another block. And okay, half of the word will go into one block and half of the word will go into another block, correct? And therefore, you cannot feed the block exactly to the mapper because the way we wrote our mapper, it was understanding lines. It was understanding that the word is available in full rather than half. All right. So the way it is done is on top of each block we create a logical representation of the block called input split. Okay, today we will try to explain that and we'll go into more and more detail about it. Okay. no worries if it's not clear. So Vikas will again discuss it. All right. Now let's talk about MapReduce in Java. So do you guys want to take a break or should we continue? I'm okay either way. All right. Let's take a break, a quick break of again 5 minutes. All right. Yeah. All right. So yeah, I'm back. So I'm starting now. So yes, that video, there was a little bit confusion. Actually, that label was saying that it's a old recorded video, but it was actually the correct one. Okay. The video was actually uploaded yesterday itself. Okay. It's just that label which said old recorded video was not changed, and that is why the confusion was there. All right. Now let's move on here. So MapReduce, the one which talked about till now, we showed you an example in the yesterday session, the streaming case. Streaming case is great for lot of uh, almost all the use cases, but there are reasons why we still want to do MapReduce in Java. First, there is a primary support. As we all know that Hadoop was written in Java. Therefore, we can modify a lot of behavior of Hadoop using Java. Okay. So, how many of you actually went through my Java sessions? Were you able to go through the Java sessions? Okay. So even the first session was like was not simple. Y- Okay. Okay. Maybe I need to evaluate. Thank you, Sanjay, for the input. Okay. Okay. Maybe I need to examine it again. What is it that? So, Vinay, when you look at your my courses, okay, so, all right. So under my courses, you will see multiple courses. One will be 18 April, and then there will be something called Java. Okay. One will be this, and other will be probably where is Java? Yeah, here is. You'll see this one. Okay. Under that, there is a Java course. And one more thing I wanted to ask you that here, if you scroll down a bit, there is a regular expression session here. Do you see a regular expression session? Okay. Did anybody went through the regular expression session? It's total 1.5 hours. Was it okay? Was it useful? All right. Just go through that. make sure that you go through a regex, because it'll be used in pig, it used in other sessions as well. So, and in general life, even if not in big data, but in general life also, regular expressions are fairly useful thing. It's quite useful thing for all. Okay. So even in the sales team, I used to make sure that everybody learns Excel sheet and learns regular expressions. Okay. So, so go through that. All right. So now I want to write MapReduce in Java end to end, and then basically we will start with word count and then we'll go deep. All right. So do not worry. Try to correlate it with the pseudocode which we wrote here. This pseudocode. Try to correlate it with. All right. Now, all right. So first of all, install Eclipse. You can download Eclipse and install. It's free and open source, so that should not be much of a problem. Just look for a appropriate version. So we can say download Eclipse. Okay. And you can download the Eclipse for Java developer. This should be good enough. Okay. This should be good enough. All right. You can say simply download. Here you can see Linux 32-bit, Linux 64-bit, Mac OS. So use the 64-bit, that is better to use. And provided you have a machine which supports 64-bit. Generally, if you're on Windows, you can right click on my computer and you can see whether it's 32-bit or 64-bit. In case you are on Mac, you can have a go to command terminal and you name minus a. If it says here 64, okay, that means it's 64-bit. If it says I38 something, then it is 32-bit. All right. So there won't be much of a difference between Luna or another one. Okay. You can use any of those. It won't be much of a problem. Okay. So you download Eclipse, install it, and then in my case, I have already installed. Oh, I'm getting these errors because I've upgraded this OS of my. So under download, you will have, I mean, in case of Eclipse, you can simply unzip it and that's good. That should be good enough. Okay. And here it's telling me that I need to, so echo dollar java underscore home is this. Okay. And I can say, Looks like I have. Alright, never mind. I think we will just try to do it in Luna itself. So install the Eclipse, and the project whatever we are going to talk today, it's available in the session 4 files. Okay. Uh, this one has collections. It one okay. It doesn't have my. It does not. It's not there. Anyway, I'll just download the way I'm telling you. So I will just go here under session number 4. I will just download this file. This is the sample project which we are going to talk. Okay, we'll just download it. Not really, not really. It's just that it is taking a bit of time for me because I was not expecting it not to work. All right. So here is our project. So basically, once you download it and unzip it, you will see these kind of folders. One will be the library. These are the all libraries that are required. And second is the source of the project. Okay. Inside your Eclipse, once you have created a new, say, new project, you basically new, how do you go? New project. Let's just say Java from Java project, and we change the location. I'm going to just pick the same folder. I am going to pick the same folder what we are talking here. Okay, and it is here, and next is I'll just go next and then finish. Okay, now it will give a lot of errors, and that's when you just go into the properties, go to Java build path, remove all libraries from here, Okay, and remove these libraries. Add your, you can say add external jars, and under here these libraries you can just select all and say okay, and that should be good. Okay. All right. So in my case, the JRE location was wrong, so I fixed those location. Now we have a working project. All right. Okay. How do you change it? Yeah. All right. So basically, this OS has recently upgraded, and that's what is confusing me a little bit. All right. Now let me try to increase the font. Oh, here it is. Is it visible now? All right. So now I am on the back on the track. So we installed Eclipse after you can download it and run it. We created a new project and we specify the location of the project same as what we have downloaded. And after that, we added all the libraries, although these 2 or 3 libraries are sufficient. And then you can basically, actually now Java 7 is good enough. No need to change it. Okay, no need to change it. No need to change right now because everywhere now it's acceptable. Okay, so we did 2 things. First, installed Eclipse, created a project, imported the code, and then added these libraries. And what does these signify? I'll just explain to you a little bit why do we need to generally change the JDK settings. So in your case, the JDK might be set to 8 or something else. Okay, so here if you take a look, where is the build, Java build? I'll just right click and say properties, and there you see Java build path. Under that there is, okay, all right. So right now I don't have Java 6 installed on this machine. Ideally it should be there. This newer versions have removed them. Okay, so the idea here is that whenever you are compiling your code, your code will should be compatible with smallest version of Java, or a version which is no which is fairly old enough, so that your code should work in almost all the environment. So whenever you are writing a code which is portable, which need to be moved to some other machine, you should always compile it to a lower version of Java, which is guaranteed to be available on all the all on most of the machines. Okay, so right now I'm just going ahead with 7.0, but if you have 6.0 on your machine, you should use that one. Okay, because if you compile your code for say 1.6 or Java 6, it will run on Java 7, but not the other way. Meaning, if you compile your code for Java 7, it will not run on Java 6. Okay? But other way around, it's correct. So whenever you are writing any portable code which is need to be sent to somebody, you should always make sure your JDK level is, you know, modest enough. Okay? So, is everybody with me, or did I get disconnected from you guys while I was fiddling around with Eclipse? Yeah, you have to change JDK here itself. Generally, generally you can just right click here. Generally, you can right click here, right click here, and click on Java build path. You will see these libraries, and there you can see the JRE, and you can also see Java compiler. Here you can set the compliance level to 1.6. Okay. So you basically tend to, I mean, even if JDK you are not changing, even if you are not changing JDK, make sure that this is at least set to something, okay? Something lower version. So as you can see here, if you right click on this and go to, you can actually set to a very lowest, but 1.6 is good enough because 1.6 is installed properly, okay? Install is a very common system and is fairly old. Okay, all right. Next is that you basically right click on it and say export, and then you say okay, and you specify the archive name. So let's call it my mr.jar. Okay, so it will create the bundle of our project after compiling, and all right, and then that will be the one. Okay, before we go on to the deploying it, let's just go through code. Okay, so first part of the code is writing the driver. Okay, in this in this don't get confused by so too much of syntax. The meat is this, the main important piece is this. Okay, so basically in case of Java, the way you define your mapper is you extend a base class. Whenever you say that I'm trying to create a mapper, you indicate it by saying that I'm extending a mapper class. And how am I extending? My input key value pairs are of data type object and text, and the output key value pairs are of type text and long writable. Why? Because the output our mapper is going to give is word, comma, a number, right? And therefore the output is going to be text as the key, and long as the value. Okay, long is a number. So why I have done long? Because it's safer to have long because if the number grows bigger, it is easier to accumulate there. All right. Whatever data type you are defining here, you are saying that my mapper reducer is of this kind, meaning it takes input, this kind of input and this kind of output. All right. Also note that in case of the mapper itself, by default it gives you the input in the form of key and the value. For the mapper itself, the input that is coming in is of the form key and the value. The key is byte offset, on which byte this particular line was found, and this text is the input line. For each input line, you also get which byte it is starting at. Okay, and then you have to write a function called map, in which you are given the line byte count and then the line. This is the line, the second argument. And context is the way you will be into the context you will be writing your key values. Okay, so you will saying context dot write, this is your first key and this is your first value. And what's happening in between? So first of all, you picked up the line that is value. Okay, we are not doing much with the key. Key is the byte count, meaning something like a line number. We'll talk about it. Okay, and the value, so value is of text type. So we first convert it to normal string, split it by space, and then after splitting, it will become an array of words. We iterate over array of words, and for each of the words, we print it out into the we print it out to context. Okay, we are handing over our key value. This is our key value. We are generating key value here. So this is key, new text, meaning we are wrapping our string into a text and handing over to Hadoop. Okay, because Hadoop guys came up with new data type called text, which is a wrapper over a string. So we need to hand over in the form of text. Okay. Okay, is the first two byte offset and input lines are always same for all example? Yes. For the same input split kinds, for the same record kinds, we will show you there is something called record type. We can specify this. For the for the text input, the byte offset is same for all. Vikas's question is, instead of writing new long writable, can we simply write one? No. Reason being that since it has to be serialized, and Hadoop guys thought that the serializer given by Java is not good enough, so they wrote their own wrapper classes. Okay, wrapper classes are like boxing, meaning you take an elementary stuff, put it inside the box, and then hand it over. Okay, so here we are basically putting a the wrapping paper called long writable over one. We are saying new long writable. Basically we're creating this big object in which we are putting one and then handing it over. Okay. Okay, so Nitika was probably asking to repeat something about byte offset, right? So whenever our data is of text type, the first argument mapper gets is byte offset. Otherwise, it is different. Okay. All right, that was our mapper. All we did was we took a line was provided to us in this function, and all we did was we splitted that line by into words, and then we iterated over words and printed out key value pairs. Now we create another class called reducer, so you can see it in our actual code. So here, this is my step mapper. Okay, and again, so what is the context here? So you might be thinking that what is the context? Context is the pipe in which we will be throwing our key value pairs. Okay, the mapper will be handing over to context the key and the value. Instead of writing it to the standard output, it'll be handing over to the context. So you can see context.write. Okay. Okay. So yeah, good question, Sweta. So for each line, your class, this function is going to be executed. Okay. On each machine, stub mapper class is going to be instantiated once, meaning somewhere somebody would be doing stub mapper, new stub mapper, and then on top of that object, the map function will be called again and again for each line. Okay. So processing next line is the duty of Hadoop, and after reading that next line, calling your map method is the duty of Hadoop. Okay. Now context. Let me speak. I think somebody misses it. Now context is the object into which you will be handing over your key value pairs. Okay, you will be writing saying context.write, and this is my key and this is my value. So you got three things in map. One was byte count, second was the actual input line, third one was this object called context. Okay, so you take the line, which is the second argument, you split it and then push it into the context as key value pair. Right. All right. Yeah, it's an object. So in here you can see this. You can see. All right. So same code. Let me hide this section. Okay. The mapper code also looks very similar. Okay. Here it's a reducer code also looks very similar. Now in reducer, there will be an input, input key, input value, output key, output value. These are the data types, and same data type would be here automatically. If you make a difference here, it will give an error. Okay. Same, whatever data type you have defined here, those same data type will be here. Okay. So long writable, text, text, text. Okay. So basically in stub reducer, you are saying that this class is a reducer. It's extending the reducer, and it takes these key value types and gives out these key value types. Okay. And the reduce function basically gets the key an array of values, an iterator over this array of values. Okay. This is what reducer gets. Now it's clear. I think Harshal was asking that. So okay, and the context. All right. Now all we did here was we iterated through all the values and generated total sum of those, and then printed again this key and the value. Make sense? So Vinay's question is, are any of these signatures changing the mapper and reducer in Java 8? I don't think so. Okay. They change when the Hadoop versions change. Okay. The only thing is people are working on something called lambda function. Instead of extending these classes like this, okay, anonymously you can create those functions and use. So yeah, so people are working on something called lambda function, similar to anonymous functions, so that you don't have to create the full class for each of these function definitions. Great. All right. So, but I'll need to check if lambda functions. Let me note it down. Lambda functions Hadoop. I'm very sure about Apache Spark. They have made the life a little simpler of extending by having those anonymous functions instead of keeping creating one class for each. All right. Similarly, we have reducer here, same code, the real version of it. And now, once you're done with writing your mapper and reducer, you write something called a driver. Okay. What is a driver? Driver basically is the entry point of the whole thing. Driver tells that, by the way of driver, you tell Hadoop that this is your input folder, this is my output folder, and this is my mapper, this is my reducer, these many number of reducer tasks I want to execute, and so on. Okay, and this is the data type I am expecting in the input. So step driver is the one which binds all of these things together. Okay, this is just argument check. Second is we first create something called conf and then go through that. And here this is the normal syntax. Here we are telling the job that this is my mapper class, whatever we just defined, stub mapper. This is my reducer class. This is my output data type, and this is my again output value type. Okay, so these basically I'm specifying to Hadoop that this is the data we are talking about. Similarly, here we are adding to the job that this is my input file and this is my output folder. Okay, Vikas's question is, can you please tell why we write set jar by class? Generally, it is for when we say set jar by classes, if you double click jar, this stub driver's main method will get executed. Line number 24 versus line number 26. Yeah, one is overall output of your MapReduce task, and this is the output of only the mapper. Okay, line number 18. Yeah, so yeah, line number 18 is, you see when you sometimes when you double click a jar and something happens. Okay, so what happens when you double click a jar is whatever is the class set by default for that jar is executed. If you think about jar file, a jar file is nothing but a zip folder. Okay, it's a zipped folder. Okay, now when you double click this jar file, which program should be executed is defined by set by jar. Okay, but this is more like a syntax thing. Oh, sorry, I'm telling a different thing altogether. Here job.set jar by class is basically we are telling job that this is our driver class. That's all. Okay, it's sort of compulsory. And line number 17, yeah, line number 17 is the initial one. This is the conf. Okay, First, we created a configuration for Hadoop. On top of it, we created a job object. And on the job object, we are setting various things. And in this job object itself, we will also set job.set. Okay. We can set things like how many map attempts are required and all that. Okay. I'm just looking for, yeah. So there will be something called conf.set set. All right. Mm, yeah. So what are we talking about? Line what? 24. Yeah. Here, what is the word count in line number 17? It's the name of the job. When you are running it, that is what will be displayed. When you are going through all the job, this name will be displayed that this particular job is being run. Okay? In 17. Okay? Now moving ahead. All right? Next is we export the jar, select the folder. My mr.jar is the name of this one. Now we will copy it to the server. If you have SCP installed on your machine, if you are on Unix, SCP will be there. In case you are on Windows machine, download WinSCP. Okay, you can download WinSCP from net. Okay, and then use. So let me just copy my, what was that, my mr.jar. Where did I export it? File, export this, and where did I? Not here. I'm supposed to my mr.jar. Okay. So I've exported it into my mr.jar. You can see now it has come, and I'm copying it to student at Hadoop 1. All right, Hadoop 1 dot no big data. Not like this. You have to say colon your folder name. Now it will copy to server into my folder. Okay, you have more questions. Line number 30 in the same one, line number 30. Yeah, here what we are saying, line number 30. Yes, Huda, it is installed by default on iOS. Yeah. So I think you're talking about Mac OS, right? Not iOS. If you're on MacBook, then it is installed already. All right. Here, line number 30, you can see here we are waiting for the job to complete. We started the job and we are waiting for the job to complete. And the last line is, in case the result, whatever is the result, you exit the JVM. If you don't exit the JVM, it will keep running and it will never end. Okay. That answers Vikas's question probably. All right. So now it's asking for password. It has copied it. Let me SSH student at hadoop1.nobigdata.com. So remember we copied onto our folder, my folder, and here you will see my mr.jar. You see that? Yeah. Now next is that we take it, we can run it like this. Okay. I'll explain to you my command. What is it that I'm trying to execute? Okay. What am I trying to execute is this command. Hadoop jar, and the one which I just created is my mr.jar. Do you see that? And then entry point. Stub driver is my entry point. Okay. And the place where our data is stored, does anybody remember? It is inside sgiri slash word count slash input, and output is sgiri slash word count slash output mr. Okay. Now you can see, is everything clear in this one? These are the argument to my program, my stub driver program. What does stub driver has? It takes these arguments here. Okay. These are the arguments provided to this program, and argument 0 is set as input path, argument 1 is set as output path. If we had hard coded these values here, then we did not need to provide these two arguments. We could have just executed like this. Right. So, Vikas, there I actually confused two different things. Here we are telling the job that our driver name is this. Okay. We are telling the job that our driver name is this. That whatever the one which I was telling, the default jar is something which we specify in our meta inf file, not here. Okay. So we have, that is why. Okay. All right, I need to yeah. So these folders, Sweta, these folders are in HDFS. Is that what you meant? Both of these need to be HDFS. Okay. This one will be created, output MR, and this one will be already there. Okay. So now I'm executing. Let's see how many errors do I get. Oh, looks like it's running. And whenever it runs, it gives us a URL to track. Okay, it says that it's yet to refresh. Yeah, so it's running on Hadoop 4. Although we are launching from Hadoop 1, it's running on Hadoop 4. Okay, you can see what's going on inside it by seeing the logs. Okay, so looks like there is an error. Let's see what is the error. Class not found. It says stub mapper not found. Okay, why it is so? Because stub stub mapper not found, meaning stub mapper is there. Okay, stub reducer is there. All right. Let me just try to. I think there's something wrong with the way it's creating my jar. All right. I think I have need to figure this out. So if I say file and then I say export and I say jar. Oh, here is the jar. I'm so sorry. Yeah, this is better. I think this will work now. All right. My mr.jar. Actually, I was saving it like yeah. So I think I got it now. Let me generate again. So file, export, and then jar file. And let me check if I selected everything. Why doesn't it select everything? Export the generated files. Okay. Export all output and everything. And into this folder. Okay. Now let me copy it. Those guys who have not heard about rsync, rsync remotely syncs two folder structures and you should definitely try it out. Okay. Even for copying music, you can use rsync. It remotely copies the files and optimizes the transfer. So what does it say? Output folder already exists. Let's see how many errors do I get now. So it says that class stub mapper is not found. This is strange. Is it not being generated or something? File, again export. my map are. Okay, so bear with me. All right, now if I run it, output MR18. Let's wait a little bit on what exactly happens. It says Java lang class not found. Probably the file is not being copied. Never mind, I'll have a look at it why it's not running. I think it's not being copied. So if you are in such a doubt, you generally need to expand it. And there is a class file already there. All right. Yeah, I'll have a look at it. I'll have a look at it and we'll discuss it in the next session. Okay. Most likely I might have to move everything into a package and then run it and then see what exactly is missing over here. All right. And the last thing I would like to check is this. Jar finished exported with warnings, exported with compile warnings on this. Oh, okay. Never mind. I'll have a check at it. Most likely it is going to be minor the compiler issues here and there. Okay. And maybe I have to move everything into a package. All right. All right. I'll have a look at it. No worries. No, we don't have to move jar into HDFS. So yeah. So you can execute the jar right away from the command prompt. You don't have to copy this to HDFS before executing, but input folder and output folder need to be in the HDFS. Output folder will be created in HDFS, while input folder has to be there in HDFS. Yeah, we will once we go through this example, then you'll have more questions and then we can discuss. Okay. And the test case also, we'll go through the test case again and you will have an idea. And probably a better idea would be to actually download this one, which has everything in it. And in case you are more interested into MapReduce, you might like to read this book called Definitive Guide. I have given the reference on the website itself. Okay. All right. So we will discuss a lot of things. So now I am actually, we are one session behind, but no worries. We will take care of it. All right. Okay then. Yeah. All right then. Because I have just upgraded my Mac to some other version, and because of which my Java 6 has gone for a toss, these kind of things are happening. All right. Any other questions before we start today? All right. Okay then. Feel free to drop me an email if you have any doubt. And also, those who have not set up a slot for 30 minutes so that we can set up and you can get up and running, please set it up quickly as possible. Try to set it up by Monday, Tuesday, or Wednesday itself. Suggest a 3 time slots. Drop an email. Drop an email to uh, hadoop@nobigdata.com and suggest your 3 different time slots of 30 minutes each so that we can set it up. Okay. Okay. I'll have a look at it, Vikas. Thank you for sharing your project. Uh, okay. Yeah. All right then. Bye bye. Have a good week ahead.